Alright, with this one, we're just going to go ahead and continue from the previous pencast, and we're just going to keep on graphing. So remember, this will be 2 parts. If you're missing something, make sure that you look at the previous video where some of that stuff is going to be explained. Alright, so now let's try sketching y equals sine x and y equals 1/4 sine x. Alright, so let's see if we can do this. We know that this one has an amplitude of 1, has a period of 2 pi, and has a frequency of 1/2 pi. We just know this about sine x. What about this one? Well, the amplitude changes to 1/4. That means the y values change as well. The period, well, let's look at b. What's the b value? The b is still a 1. So the period doesn't change from the original sine x. The period is still 2 pi. And the frequency is still 1/2 pi. So what are the implications here? X values remain the same. So we're going to have the same X values, but we're going to have different Y values. So then you go ahead and you set up your sketch. Your sketch is going to go as high as 1, and 1/4 is less than 1. So we'll be fine. Like this. The highest needs to be 1, lowest needs to be -1, and our points are going to be 0, pi/2, pi, 3/2 pi, 2 pi. I'm drawing the original one. It's going to go as high as this. Intersect, low is -1. Remember I said, think about semicircles when you do this. Semicircles when we're doing this. Alright, so we have the original y equals sine x. Now we have to plot the other one. The other one has an amplitude of 1/4. It has the same x values. So it's going to cross here, but over here it's only going to go up to 1/4. Then it's going to intercept, and then it's only going to go as low as 1/4. And then over here. So let me go ahead and dash this, and there you have it. Y equals 1/4 sine x. Alright, let's do an example where b changes, and we'll use cosine this time. Alright, y equals cosine x versus y equals cosine 1/3 x. As you can see right now, we've had a change in b. Right? So a equals 1, b equals 1/3. So what does this mean? This means that the amp and y values remain the same. But this means that the period and x values change. Okay? So we're going to have new x values for this other function. Alright, amplitude for the cosine is 1, period is 2 pi, frequency is 1 wave in 2 pi. For the new curve that we have, the amplitude is 1. The period is 2 pi over b, so 2 pi over 1/3. And in terms of math, that is 2 pi times 3/1, so 6 pi. So the period is 6 pi. And the frequency is going to be 1/6 pi. So that means one of these curves is going to take as long as 6 pi. So this curve is going to be 3 times longer than the regular cosine curve, because the period is 3 times longer. This period is 2 pi. 2 pi times 3 is 6 pi. So it takes 3 times as long for this wave to be completed, whereas the cosine can be completed. So we're going to have to be careful. You have to physically understand what's going on. Or another way of thinking about it is every 3 cosine curves is going to be 1 cosine 1/3 curve. So it's going to be 3 times as long. We got to be careful when we're sketching this. So let's say this is 1 cosine curve, 2 cosine curves, 3 cosine curves. So this is going to be fun plotting. Alright, cosine is going to have your basic shape. I already know it's going to be at pi halves, pi, 3 halves pi, 2 pi. Let me sketch my difference. 2 pi, 4 pi, 6 pi. Cosine, let's say that we start at 1. The amplitude doesn't change, so I don't have to worry about that. -1. So that's my maximum. I'm going to cross. I'm going to go to my minimum. And go to my maximum. Okay? So this is 1 cosine curve. Y equals cosine x. Alright, now the other one. Well, the problem is my x values have changed, so I need to know my new x values. I know the amplitude, and that's fine. It's only going to go up to highest 1. Alright, in order to change the x values, we had said that we know that it starts at 0 and it ends at 6 pi. Well, we have to get these points, right, where it's going to do this, right, it's going to do this, come back up, and it's going to do that. So we need to know these points. In class, we had said that we were going to do 1/4 of the period, 2/4 of the period, and 3/4 of the period. Okay, so here we go. 1/4 of the period. The period is 6 pi. So that is 2 times 2, 2 times 3, 3 over 2 pi. So that's this first point right here. Oh, look, we already have it. So that's going to be this point right here. Alright, the next point is 2/4 over pi. 2/4 of the period. The period being 6 pi. Let's see. That cancels out one of the 2's. Right, I got a 2 left over, and this is 2 times 3. Cancels this, and I'm left with 3. So this is 3 pi. Alright, this is this point right here. So 3 pi, so that's 2 pi, that's 4 pi. 3 pi would be over here. Okay? Make them bigger so that you can see these points. Alright, we need the last one. This one right here. And it's going to be 3 over 4 times the period. The period is 6 pi. And let's see. 6 is 2 times 3, so that cancels one of the 2's here. So this is 3 times 3 is 9. 9 over 2 pi. And I don't know where that is, but I know it's going to be somewhere over here because obviously we're cutting this into fourths. So 9 pi over 2. And so we go on. It's still a cosine curve, so it's still going to start here. So it's going to do this. It's going to hit a minimum over here. Right? So it's going to do this. Come back up, hit here. And it's going to hit a maximum over here. See? Like I said, it was 3 times bigger. So you literally have like 3 of the original ones in the distance of this long one. So y equals cosine 1/3 x. Alright, thanks for watching.